Practice set 1.3, sum number 4. In triangle ABC, AP is perpendicular to BC, BQ is perpendicular to AC. Between us is given to us, that is B dash P dash C, comma A dash Q dash C. Then prove that triangle CPA is similar to triangle CQB. If AP is equal to 7, BQ is equal to 8, BC is equal to 12, then find AC. Now, if you look at the question, there are two parts of the question. In the first part, we need to prove triangle similar. In the second part, we need to find AC. Let us look at both the triangles. The first triangle is CPA. In that triangle, angle CPA is 90. The second triangle is CQB. In that triangle CQB, angle CQB is 90. And since there are only three sides given to us, the only option is a test of similarity. So let us start with the proof. In triangle CPA and triangle CQB, angle CPA is congruent to angle CQB, each angle 90 degree. Now to find the second angle, we are going to separate both the triangles. Now if you look at the triangles, angle C is common. So let us write the next step. Angle C is congruent to angle C, common angle. Therefore, triangle CPA similar to triangle CQB by a test of similarity. Now, once the similarity is done, we need to find AC. To find AC in similar triangles, we need to find the ratios, and we know it. Since the triangles are similar, the ratios are equal. Therefore, AP upon BQ is equal to AC upon BC. This is by corresponding sides of similar triangle. Therefore, AP is 7 upon BQ is 8 is equal to AC is not given. Upon BC, we need to find BC, that is 12. To find AC, we need to cross multiply. So let us cross multiply. 7 into 12 is equal to AC into 8. Therefore, 7 into 12 upon 8 is equal to AC. 12 and 8 are divisible by 4. So 4 2s are, 4 3s are. 7 into 3 will give me 21 upon 2, and 21 divided by 2 is nothing but 10.5. So therefore AC is equal to 10.5. Thank you.